All right. So at the start of the chapter, we have to figure out whether this is a polynomial function or not. Are we dividing by any variables? Uh-oh. That's me. There we go.
Yeah, seriously.
Seriously,
Busy man.
I've got a lot going on.
So just graph it.
All right, there we go. So, are we dividing by a variable? Do we have a variable inside a square root on this? Any of that? So, it is a polynomial function. What's the degree of this function? 4, because that's the highest degree variable that appears. The leading coefficient is the coefficient of the highest degree polynomial that appears, highest degree variable that appears, so it's 2. Okay? What's the correct graph for this? Well, it's derived from x squared, right? The minus 2 does what to it? Right? 2. The minus 3 does what to it? Down 3. And 2 here makes it twice as high. So instead of being at 1, 1, because we start out at 0, 0, and then we go to 1, 1. So instead of that, this will make it go to 1, 2. So it'll be skinnier, basically. Okay? So over to the right 2, down 3, to the right 2, down 3. The only one that hits right 2 and down 3 is this one, isn't it? Okay. The correct graph has a parabola with a vertex at, and there I go again, grabbing the wrong thing. At right 2, down 3. The correct graph opens up and passes the point 1 what and 3 what? Well, we have to go up 2 from this negative 3 because we go over 1 and up 2 instead of over 1 and up 1 like normally. Okay? So if we go up 2, it's 1, negative 1, and 3, negative 1. Are you good with that? Okay. X squared plus, and what if you can't figure this out? What should you do? Graph it on your graphing calculator and use the what function? Trace. Use the trace function. Trace to 1 and you'll get negative 1. Trace to 3, you'll get negative 1. Okay? So the graphing calculators can help you out there. All right. Graphing this, we complete the square to figure out what equation it is. So it's x squared minus 6x plus blank plus 13 minus blank, because whatever we add, we have to also subtract. What's half of 6? 3. 3 squared is? 9. So we're going to add and subtract 9 to this. So it's going to be x minus 3 quantity squared. That's this, because we made a perfect square trinomial. So that's our squared after we factor it. 13 minus 9 is plus 4. So it's this one here is the correct answer. Okay? So what is that graph? Well, it's a parabola. It's an upward opening with a vertex of what? Negative 3, 4. Negative 3, positive 4. Oh, positive 3, positive 4. You are correct, because it's the opposite of the inside, same as the outside. Okay? Axis of symmetry is at x equals 3. So if we just look at 3, 4 over 3 up 4, it's here. And if it opens up, is it going to have any x-intercepts? No, the parabola does not intercept the x-axis. Okay. Okay. The fourth root of x is going to look like a graph like that. Okay. The power is 1/4 because it's the fourth root. The constant of variation is 1/2. Okay. Because that's the number in front of x. That's y equals kx. So k is a constant of variation. All right. The domain of this function, it starts at 0, 0 and goes forever. So the domain is 0 to infinity because it'll keep going up just slightly. And the range goes from 0 also to infinity. Okay. Oh, is it odd, even, or neither? Does it flip over the x-axis? No. Does it flip over both the x-axis and y-axis? No. So it would be neither. I'm pretty sure that's right. Let me just check, make sure Mr. Bierschbach's right, because I don't like telling lies. Yep, it's neither. All right, 5. How do we transform this? What does the plus 2 do? Left 2. So it's translated 2 units to the left. And it's stretched vertically by a factor of 4. Okay? So 2 units to the left is right here. Instead of going over 1 up 1, I'm going over 1 up 4. So it's a really skinny graph like this. Okay? And then instead of going over 2 up 4, I'm going over 2 up 16. Okay? So the y-intercept is at 16. All right. These are each place where the graph crosses the x-axis at 1, -3, and -5. 1, -3, and -5. +1, -3, -5. Okay? So it looks like this one's the 1. If there would be a power on here, like the squared, then it would bounce on the x-axis. But if they're all to an odd power, then it's going to cross the x-axis there. Okay? And since this is positive, okay, there's not a negative in front, it's going to start down and end up. So as you go to the right towards infinity, it'll go up to infinity. As you go towards negative infinity, it'll go down to negative infinity. So as you go left, it goes down. As you go right, it goes up. What are the zeros of the function? Well, it's x times x squared minus 2x minus 8. So it's x times x minus 4 times x plus 2. So the zeros are 0, 4, and -2. Synthetic division, you throw a -5 here. Why do I use -5 instead of 5? Because it makes whatever makes this 0. And so it's 3, 18, 11, -23. And so 3, -15, 3, -15, -4, 23. Okay, so it's 3v squared plus 3v minus 4. Oops, and that's a -3. Minus 3 over v plus 5. Okay, remainder theorem. So simply you take a 3 here and go 3, -14, 14, and figure what the remainder is. 3, 9, -5, -15, -1, remainder's -1. Use the factor theorem to figure out if it's a factor. So we stick -5 here and go 1, 7, 2, -40. 1, -5, 2, -10, -8, +40, 0. If this is a 0, yes, it's a factor. If it's not a 0, no, it's not a factor. Okay? What are the possible roots of this? Well, 1, 3, 7, 21 goes into there, divided by 1. And so it's plus or minus all these. What are the roots of these? Well, that's where you just start trying. 1, 3, -25, 21. You try a 1 first. 1, 1, 4, 4. What is that? 21? -21, -21, 0. Hey, that worked right off the bat. So if this is x cubed, then it's x squared. So it's x squared plus x minus 21. Then that just factors x minus 7, x plus 7, x minus 3. So our roots are 1, -7, and +3. 1, -7, +3. For this, you have to FOIL. Now, when I get imaginary roots, I use the sum of the roots, product of the roots. What's the sum of 7i and -7i? 0. What's the product of 7i times -7i?
40.
+49. So this is x squared plus 49. And then you take it times x minus 6 times x minus 6, which is x squared minus 12x plus 36. And you double distribute. So it's x to the fourth minus 12x to the third plus 36x squared plus 49x squared minus whatever 49 times 12 is, I don't know, and whatever 36 times 12 is. And then you just add your middle two terms. Okay? I'll let you guys figure, well, let's keep going with that. Okay. Somebody, 12 times 49 with the calculator, please.
588.
What?
588.
And then 36 times 49.
1764.
So it's x to the fourth minus 12x cubed plus 85x squared minus 588x plus 764. Okay? That is the function. The zeros are at 6. Okay? And then it says express complex terms in terms of I. So it's -7i and 7i. The x-intercept is just 6 because if it's imaginary, it's not an x-intercept. Okay? 5 has a multiplicity of 2, so it's x minus 5 squared. 4 plus I has a multiplicity of 1, so it's x minus 4 plus I. And the other root is x minus 4, x minus 4 minus I. So it's x minus 10x, or x squared minus 10x plus 25 times, this would be x minus 4 minus I times x minus 4 plus I. But if we go the sum of 4 plus I and 4 minus I, that would be 8. Their product, if we'd FOIL that, 4 plus I times 4 minus I, it'd be 16. Outers and inners cancel. Minus I squared. Minus I squared is plus 1. So 16 plus 1 is 17. So it's x squared minus 10x plus 25 times x squared plus or minus 8x. X squared minus the sum of the roots x. So minus 8x plus 17. And you double distribute that, and whatever that answer you get there. Okay? So that one's a little bit a longer one. Okay, If 3i is a 0 of this, another 0 would be negative 3i. Because they always come in conjugate pairs. Okay? So what makes 3i a negative 3i? Well, x squared plus 9 makes 3i a negative 3i. Okay? Because you multiply them to get negative 9i squared, which is plus 9, and then they add up to 0. So this is where you use long division to figure out what everything else is. So if we distribute, you get x squared, so it's x to the fourth minus or plus 9x squared. Change the signs on the bottom row and then add, you get negative 3x squared minus 27. What times x squared is negative 3x squared? Negative 3. So it's negative 3x squared minus 27. So x squared minus 3 factors into x plus square root of 3 and x minus square root of 3. So it's negative 3i, negative square root of 3, and positive square root of 3. So the linear factorization is x minus 3i, x plus 3i, x minus square root of 3, and x plus square root of 3. The domain of this function can be all real numbers except for negative 5. So it's a function that looks like this, that has an asymptote at negative 5. So it goes like this, and it goes like this. Okay? So as you're going towards negative 5 from the left, where does it head? Down to negative infinity. As you head towards negative 5 from the right, it goes up towards infinity. Asymptotes, x minus 4, x plus 2. And then the power on the top is higher than the power on the bottom, so the horizontal asymptote is y equals 0. Okay? When the power on the top is lower than the power on the bottom, it's y equals 0. Vertical asymptotes are at x equals 4 and x equals negative 2. So the leftmost is negative 2, the rightmost is 4. X-intercepts is when you set your numerator equals 0. Well, then that is 3. The y-intercepts are when you plug 0 in, so that, whoa, go back there. Go back. Stop. Be nice. Oh. Close enough. So the y-intercepts is if you stick 0 in, you get negative 3 over negative 8, which is 3/8. So we have a horizontal asymptote of 0. You have a y-intercept at 3/8. You have vertical asymptotes of 4 and negative 2. So it looks something like this, I would guess. You can just graph it on your graphing calculator to see. And this is what we did the last time. Multiply everything by x minus 3 in the numerator. So these cancel, so you don't do anything with them. Take x times x minus 3, which is x squared minus 3x plus 7x equals 21. So if you move it over, x squared plus 4x minus 21 equals 0. So x minus 3 times x plus 7 equals 0. So x equals 3 and negative 7. If you plug those in, you can see that 3 will make the denominator 0, so that is an extraneous root. So the only root is x equals negative 7. Okay? And then this one, you do the same thing, figure it out. When it comes to here, negative 6, negative 2, and a positive 5 are the zeros. So you use a sine curve. So at -6, -2, -2, and 5. So if we try like 0 in here, 0 gives us positive times a negative. So it's negative here. And since there's no squares, it should change every time. So positive here, negative here. So where is it positive? In between -6 and -2 and past 5. It's negative on the other side of 6 and in between -2 and 5. Okay. And then the same type of thing here. Factor it. X plus 1, x minus 1, x minus 3. So -1, 1, and 3. So where is it negative? Well, if we try 0 here, in here, 0 gives us a positive times a negative, which is a positive. So it's positive here, it's negative in between here, it's positive here, and it's negative over here, because it changes every time. Where is it negative? Where is it 0? So it's less than -1 and in between 1 and 3. And since it's a less than sign, there's no brackets, there's just parentheses.